topic 3.1 notes, and we're going to be discussing all in Unit 3 or Topic 3 about polynomials. We have already learned some of the polynomial functions, like the quadratic, and some of the functions we learned at the beginning of the year when we did the parent functions. The cubic function was one of our parent functions. So we're going to focus on the quadratic and the cubic, but we're going to put it in a broader sense and talk about it as a polynomial function. So we'll start with one of the functions that you're familiar with, which is the quadratic. And we know the quadratic parent function is f of x equals x squared. We've talked about the domain and the range. So the domain, negative infinity to positive infinity, always. The range represented the lowest y value up to the highest y value. And you remember on a coordinate plane where the infinities are. So negative infinity, positive infinity on the horizontal x-axis. And then, of course, negative infinity and positive infinity on the vertical y-axis. So if we were to look at this particular quadratic graph, we would notice that it is reflected. That was one of the ones that was reflected. So the a value is negative. And it has been translated up some units, actually all the way up to 9. And so my range is going to represent the lowest y value to the highest y value. So that's going to be negative infinity to positive 9. The zeros of the quadratic. The zeros are where the function is 0. So in other words, the zeros are where f of x is equal to 0. Well, on the graph, that's your x-intercepts. But when we write them, when you are asked for zeros, you do not write them as x-intercepts. So you write it as x equals 3 and x equals negative 3. The y-intercept. That I know you can determine from the graph, so I'm going to pause Edpuzzle and let you type in the y-intercept. Okay, so hopefully you got 0, 9. The next graph is actually a variation of the cubic function. All right, so let's go down here to our polynomial notes. And so we know that f of x equals x squared is quadratic. F of x equals x cubed was called the cubic function. And if you don't remember it, the cubic function looked like this. It was in the first and third quadrant, and it went through 0, 0. And of course, then if we put a negative in front of it, it flipped. And so now we're going to talk about variations of the cubic function. So let's go back up in our notes, and let's take a look at this graph, all right? And for all of these graphs, there are arrows at the end, so I should be including those. So let's talk about the domain. Well, first of all, the domain of the cubic function is negative infinity to positive infinity. The range is also negative infinity to positive infinity. Let's pay attention to the direction of the arrows, right? If we read our function from left to right, as we did in the beginning of the year, we would see that the function is decreasing when we first approach it and increasing when we last approach it, or at the end over here in the first quadrant. So that means that it is in both directions approaching the appropriate infinities. Down here is negative infinity, and up here is positive infinity. What are the zeros? Well, the zeros are when f of x equals 0. All right, so you can see on the graph here, that's at -3, 0, and 2. So that's x equals -3, 0, and 2. And you can write it like that. Oh, and I was going to write here, this is the cubic, and that's some form of f of x equals x cubed. Now, this is not x cubed because this has more terms in it than the parent function x cubed. And we're going to talk about that. Why does it have more terms? Y-intercept, that I know you can determine from the graph, so I'm going to pause and let you type that into Edpuzzle. Okay, y-intercept 0, 0. Number 3 is another type of polynomial function. And you can see that it's similar to the quadratic in that both of the ends of the function extend in the same direction. So if you think about your quadratic, if your quadratic opens up, both of the ends of the graph are opening up. If the quadratic opens down, both of the ends open down. So both of the ends are pointing towards positive infinity. But instead of having a U, this is a W. It looks almost exactly like a W. This type of function is called a quartic function. And quartic functions are in the family of quadratics. They are f of x equals x to the 4th. This particular function has some characteristics that we're going to talk about in topic 3. One of those is what's happening at this 0 at 0. So let's go ahead and fill in some of the things that we know. First of all, and so we'll come back and talk about that 0. First of all, we know our domain, negative infinity to positive infinity. So similar to the quadratic, similar to the cubic, the quartic domain is negative infinity to positive infinity. The range, lowest y to highest y. So I'm going to let you try to type that answer into Edpuzzle. Okay, the range, -20 to positive infinity. So lowest y. Look at the lowest y there. It's right here. Right? That's your lowest y. Your zeros. Okay, well, let's look. There's a 0 at -3, 0, and positive 3. So x equals -3, 0, and positive 3. Now, at 0, your polynomial comes up to that 0, and then it turns and it goes right back down. We call that a bounce at the 0. We call that a bounce. When your polynomial bounces, in other words, it touches the 0 and goes right back in the same direction, we say the multiplicity of the 0 is even. And again, we're going to talk about that more when we talk about the actual equations associated with these polynomials. Right now, we don't know what the equation is. We are just looking at the graphs. But there is an equation that represents those graphs. And in that equation, we're going to learn about multiplicity and what that does to the graph. Again, the y-intercept is 0, 0. Okay, let's look at the next graph. Now again, look at this polynomial. The ends of the graph point in opposite directions, as opposed to the quartic, where the ends of the graph pointed in the same direction. This is again a variation of the cubic function. And we know one of the characteristics of the cubic function, so let's go down and look at it, is that the ends of the graph point in opposite directions, as opposed to the quadratic, where both the ends point in the same direction. So they either both point up or they both point down. But your cubic, the ends of the graph point in opposite directions. So remembering what the basic form of the function looks like helps you to graph them when they have more turns. And so that's what's going on here in number 4. This graph comes down to the 0 at -3, and it turns. We actually call that a turning point, okay? So the graph turns at -3, and it goes back up to a y value of 4. And then it turns again, and it goes down towards -infinity. And so one of the things you're going to do is you're going to discuss the characteristics of the function. Not right this second, but in this topic. All right, our domain, -infinity to +infinity. Our range, well, let's look at the ends of the graph. They're both going in opposite directions. Okay, so this one is pointing towards +infinity, and this one is pointing towards -infinity. So my range, -infinity to +infinity. And I'm just reminding you that we never put brackets around infinity. Zeros. So I'm going to go ahead and let you put in Edpuzzle what the zeros are for this function. Okay, what are the zeros? And you can type it as x equals. Now we do have here another bounce. Okay, so there's a bounce there. And what that means is that the multiplicity of the 0 is even, meaning that that 0 will occur twice as a factor. So if I were to write out the equation of this polynomial, that 0, x equals -3, will turn into a factor of x plus 3. But because there's a bounce there, it'll be x plus 3 and another x plus 3. Again, we will discuss it more in future topics. Y-intercept, again, 0, 0. That was a commonality a lot here. All right, so what do we do when we don't have a graph, but we're looking at the equation? So let's look at our number 5, and we see that the equation of the function is -4x cubed plus x plus 9. And the question said determine the number of zeros, the y-intercept, and the domain. So the number of zeros, so the first thing you have to do is look at what the degree of the polynomial is. All right, so let's go down here and let's put that down, as a vocab word. Degree of a polynomial. The degree of the polynomial is the largest exponent of the leading term when the polynomial is in standard form. That is called the degree. So when you look at the equation of a polynomial, it should be in standard form. Standard form, like when it's quadratic, means it's ax squared plus bx plus c. So highest degree exponent, largest exponent, then the next largest exponent, and so on, down to a constant term, which is a number term. So if we go back up to that problem, the degree, first of all, is this polynomial in standard form. So we have x cubed, and then we have x, and then we have 9. 9 is called the constant term. So the degree of this polynomial is 3. To determine the number of zeros of a polynomial is equal to the degree. Now, we're going to talk down the road about what kind of zeros those are. Some might be real zeros. Some might be non-real. We learned non-real numbers last semester when we did imaginary numbers. So we're going to eventually talk about how do we find all those zeros. So the number of zeros for this is 3. The y-intercept. The y-intercept is what f of 0 is. So for the y-intercept, we're going to do f of 0, and that's going to be 9, and that translates into the point 0, 9. The domain, well, we know that the domain is all real numbers. All right, so the degree, that was a new vocabulary word. The degree of the polynomial is the highest exponent on the leading term when it's written in descending powers in standard form. This is a cubic function, so that x cubed. So it will behave like a cubic function. And one of the most important things to remember there is that the ends of the graph will go in opposite directions. That's important. Number 6, f of x equals negative 6x to the 4th plus 1. Well, what's the degree? The degree is 4 because that's the highest exponent. This is a quartic. So what will that look like? Well, it will behave like the quadratics, meaning the ends of the graph will go in the same direction. And that's important. The y-intercept is f of 0, and when we plug that in, we get 1. So 0, 1, and our domain, negative infinity to positive infinity. Okay, now we're going to move on to graphing and increase some of our vocabulary and review some of our vocabulary, right? So some of this is a review, some of it is new. I'm going to go ahead and highlight for you what is new. Absolute minimum, absolute maximum, relative minimum, relative maximum. On the other side of the chart, those should be things familiar from the beginning of the year. Okay, so let's take a look at number 7. All right, and let's just remind ourselves. This is negative infinity down here, positive infinity, negative infinity, positive infinity. When you look at the characteristics of a polynomial graph, now this, again, no arrows there, but we can always add them in. When we look at a polynomial function, we should always look at what is called the end behavior. What's going on at the ends of the graph? Because that helps us to know whether it is behaving like a cubic function or a quadratic quartic function. And your quartics are going to differ from your quadratics in that they will have more bumps in the middle. So there won't just be one low point or one high point as there is in a quadratic, but in a quartic, there might be a couple low points, like that W. All right, so remember when we're writing intervals, they are always x values. So intervals are always x values. We want to remember that, okay? So let's start on this curve. I'll try to do some different colors. Let's start with where the function is increasing, okay? Where are the y values going up? So I'm going to color it green. Okay, so increasing and increasing. So I'm coloring increasing green. So I'll put a little green in that chart. So how do we describe those intervals? Well, negative infinity to this point right here, but what part of that point? The x value. So that's negative 1.33. Where else? Well, right here, from 0 to positive infinity. So there are two places on the graph where the function is increasing. All right, let's switch color and let's talk about where the graph is decreasing. So it is decreasing, and again, from negative 1.33 to 0. Because again, we are describing x values, okay? Where's the graph constant? Nowhere. Where are the zeros? Well, the zeros are at x equals 2 and x equals 0, and the y-intercept is at 0, 0. So now let's talk about these words over in the extremas side of our chart. The absolute minimum of a graph is the very lowest point on the graph. So when you think of the word absolute and you think of the word minimum, we are looking for what is the absolutely lowest point on the graph. Well, let's look at this graph. When I look at when the graph is down here, so I guess if I could show you, like right where I just pointed that arrow to, you see that that graph is approaching, it's going towards negative infinity. And so if that arrow indicates infinity, the graph will never have an absolutely lowest point. So there is none. Absolute maximum. Absolute maximum. For the absolute maximum, we want the very highest point. So if I look at the other end of the function, so over here in the first quadrant, we see that that end of the curve is pointing towards infinity. So as the x values, as we, go out in x values, our y values keep getting bigger and bigger and bigger. So there is no absolutely highest point on this graph. Now let's talk about relative minimums. Well, relative minimums are any low points on the graph. And alternately, then, relative maximums are any high points. So there could be more than one of these. Could be more than one of these, any low point or any high point. So as we are increasing, and these points, the relative min and the relative max, as you would expect, they occur where the graph turns. So another name for them is the turning points. So look at our graph. We are increasing with the green, then we hit that point, and the graph turns, and then the red where I traced is where the graph is decreasing, and then we hit the green, and the graph is increasing. So relative min is that turn at 0, 0. Okay, that's a low point, and negative, and you can zoom in if you can't read it, 1.33 and 1.19 is a high point on the graph. Okay. Now for the next one, I am going to let you answer as much of this chart as you can. So I'm just going to pause Edpuzzle. You don't have to put anything in the box, but I am going to pause it. Actually, in the box, why don't you put the absolute minimum? So I'm going to put a highlight over that, put this in the box. But please fill out the whole chart. And then when you start the video again, you can compare your answers and see if you knew any of them. So try, but what's going to go in the Edpuzzle box is absolute minimum. Okay, increasing. So again, I'm going to highlight. My increasing is going to be my green part, and my decreasing is going to be my red. And of course, we know that there are arrows here, that this is positive infinity up here, negative infinity down there. Okay, so my function is increasing from 3 to infinity. So starting at x equals 3. Reminding you again that intervals are written with the x values. Decreasing negative infinity to 3. Never constant. My x-intercepts are at 1, 0, 5, 0. My y-intercept is at 0, 5. And now let's go over and talk about the new stuff. Absolute minimum. Well, this is a quadratic. There is an absolute minimum. The absolute minimum is the lowest point on the curve. So let's see if you got that right. 3, negative 4. Absolute maximum. There isn't one. Those two arrows are pointing up at the ends of the quadratic. Keeps on going. No absolute maximum. Relative minimum. Okay? The relative minimum is the same as the absolute minimum in this particular graph. Okay? Relative maximum, there is none. So you can go ahead and compare how you did with my answers. Okay, let's try another one. Let's go ahead and put the arrows at the end of the polynomial. Now, both of those arrows are pointing in the same direction. So I'm going to tell you that this is in the quartic family. Now, how do I know that? Well, it's not quadratic because we just did a quadratic, and all of you know what a quadratic looks like. This is a quartic because it has bumps in between the ends of the graph. That's how you remember a quartic, okay? Where is the graph increasing? So I'm going to color that green. So it's increasing here, right? It's going up. Your y values are going up. And here. So green for increasing, red for decreasing. Okay? So red for decreasing, green for increasing. I like to color code it because it helps. All right, so let's talk about the increasing from, because we're going to do green. So increasing from -1 to whatever that x is right there. I'm going to have to zoom in to figure out what that is. So -1 to 0.219. And then it's increasing again from 2.28 to infinity. decreasing from negative infinity to -1, because remember, no. Sorry about that. Yeah, no, I'm right. And 0.219 to 2.28. Now you think, where did these numbers come from? Well, they come from graphing and having a graphing utility that will calculate those specific points for you. If you have a graphing calculator, I can show you how to use it. If not, we're going to have to use a different tool. Okay, there are no constant intervals. Okay, the solutions, let's remember the solutions are the zeros. So x equals -1, 1, and 3. The y-intercept, now that's going to be something I don't know, right? It looks like it's about 3, so maybe we just say approximately 0, 3, but we don't know for sure. All right, let's talk about absolute min, max, relative min, relative max. So I'm going to recap our new vocabulary. Absolute minimum is the very lowest point on the graph. Now, we got that. We have that right here. That is the very lowest point. 2.28. I have to zoom in to be able to see it. 2.28, -9.91. Absolute maximum. Well, let's look at those arrows. They're pointing up. We will never reach the highest value. So that's a none. Relative min. So remember, relative min is a low point on the graph. So here's a low point, right? And here's a low point. Just so happens that that second one is also the absolute minimum. So the relative minimum, you include the absolute. So -1, 0, and then your 2.28, -9.91. Relative maximum. Remember, that is a high point. There is a high point. It's not the highest, but there is a highest. And that's 0.219 and then 3.227. Okay, so polynomial characteristics. We've talked about the degree. You know what the zeros are. You know what x and y intercepts are, right? You know increasing and decreasing intervals, because we did that already when we learned the parent functions. The new vocabulary: absolute maximum and minimum. That was new. So that's the very highest or the very lowest point. Relative maximum or minimum. And that's a high point or a low point. Okay. How many zeros does a polynomial have? Okay, this is equal to the degree. We talked about domain and range, stuff you already know. And the other two things that we talked about, but I didn't actually put a name to it, was even and odd functions, polynomial functions. So your even ones behave like the quadratic. Okay? So those are your quartic, x to the fourth, x to the sixth. And the reason they're even is both, I'm going to call them tails, which is kind of like the ends of the graph. Point in the same direction. Okay, that's even. Odd functions, they behave like the cubic function. And that is where both tails, I know it's kind of weird, but I call them tails, the ends of the graph, point in opposite directions. Now, we're going to talk about that end behavior of the graph more formally as we move through topic 3. But for now, understand that if it's in the cubic family, your ends of the graph are going to go in opposite directions. So one's going to go towards positive infinity and the other one's going to go towards negative infinity. And if it's an even function, then it's going to behave like your parabola, where the ends of the graph are going to either both be pointing up or both be pointing down. Okay, I want to scoot up here to zeros because I know that we've talked about it, but I want to make one more connection to you that the zeros are the same as the roots. They're the same as the solutions. And of course, when written, they are the x-intercepts. Okay, so let's go up here and let's just put some highlights in purple around the important stuff here. Well, everything's important. But the degree, the zeros, okay, x and y intercepts, increasing, decreasing, absolute max and min, relative max and min. How many zeros does a polynomial have? Domain, range, even, odd. Wow, a lot of stuff in this. And then the very last part was the multiplicity. And that is going to come later on. Multiplicity of a zero. And the only thing that I referenced in these notes was that visually on a graph, the multiplicity is seen as a bounce or a turning point. So your polynomial comes up and it touches the zero and bounces off and goes back down, or it's coming down to the zero and it touches and then it bounces off. So more later on that. So bounce at zero. Just to remember when I reference it later.